Hello, today our class is on measures of skewness. Okay. First, we will see the introduction of measures of skewness. Okay. An average is a single figure which gives a representative value of the series and depicts the characteristics of the whole group. Average alone cannot adequately describe the whole set of observations, as all the observations in a frequency distribution are centered alike. Okay, measures of dispersion are useful in examining the characteristics of the mass of figures in a series from an average value. However, neither the averages nor the measures of dispersion reveal the entire story of frequency distribution. Okay. Example, two distributions having the same mean and standard deviation may differ widely in their overall appearance, which can be seen with one example. uh, Here I am going to tell you that so the values of mean and standard deviation of two distributions, mean is equal to 30 and standard deviation is 1.204. Okay, it does not mean that both the distributions are alike. Okay, while the frequency distribution, uh, if you see with the okay given example, is a asymmetrical, both are, one is symmetrical and the other is asymmetrical. That means measures of skewness help to understand the nature and shape of the distribution, right? Next, definition of skewness we'll discuss. Some important definitions are given by eminent um, statisticians. Uh, According to a few, we'll discuss here. According to Riggleman and Frisbee, skewness is the lack of symmetry. Skewness itself, that means lack of symmetry. Okay, symmetry means you can divide any given particle into two equal halves, then we call it as symmetry. Lack of symmetry means one part is equal and the other is not equal. If you are not in a position to equally cut into the two halves, you are not in a position to equally distribute those given series, right? When a frequency distribution is plotted on a chart, skewness presence in the items tend to be dispersed more on one side of the mean than of the other side. As we have seen in the earlier classes, the bell-shaped normal curve, we call it as bell-shaped curve. In a bell shape, you can divide as many as equal parts. But whereas if you see in a what we call it as monograph, you will find a bell-shaped curve, normal curve. A bell-shaped curve, you can divide it into two equal halves. If you take the center as mean, mean will give us two equal halves. Okay, but whereas in case of the skewness, the symmetry is lack. Okay, lack of symmetry is there. According to Garrett, a distribution is said to be skewed when the mean and the median fall at different points in the distribution, and the balance or center of gravity is shifted to one side of the one side or the other, to left or right. It means when you see the bell-shaped curve, median, mode, and mean coincide. Whereas in a symmetric distribution, that means skewed distribution, mean is located somewhere else in the graph and the median is located somewhere else. Okay, fall at different points in the distribution, they are not coinciding. Okay, according to Garrett, right? That means uh, the center of gravity shifted to one side, that is not at the center of the bell shaped curve, but that is not at the center of the given distribution, that is shifted to one side of the uh, graph, right? Now, according to Wessel, Willett and Simon, uh, they defined lack of symmetry. Skewness is as lack of symmetry. Any measure of skewness indicates the difference between the manner in which items are distributed in a particular distribution compared with a normal distribution. Any measure of skewness indicates the difference between the manner in which items are distributed in a particular distribution compared with normal. It means it has some difference, some bias. There is no similarity with the normal distribution. When normal distribution, that is a symmetrical distribution. You can cut into two equal halves. The median and mode mean are located in the center, but it is not so according to Bessel, Willett, and Simon. It has lack of symmetry. When you compare the same with the normal distribution, it has some difference, right? According to Padden and Lindquist, okay, a distribution is said to be skewed. A distribution is said to be skewed if it is lacking symmetry. Okay, that is measure tend to pile up. Okay, at one end or the other, tend to pile up at one another. It will move. Okay, it will penetrate one side. It will not be same both sides. Right? That is called uh, skewness according to Padden and Lindquist, right? And another definition is given by Simpson and Kafka. Okay, they say that measure of skewness tell us the direction and the extent of skewness. Measure of skewness tell us the direction. Okay, in which direction the distribution is proceeding and what extent the skewness is found. Okay, what extent the disparity we call it as found in the given distribution. In symmetric distribution, the mean, median, mode are identical. Okay, identical. And the more the mean moves away from the mode, the larger the asymmetry or skewness. Okay, they coincide in case of normal distribution and asymmetric distribution. But whereas in case of skewness, okay, increases the mode and mean moves away from one another. Okay, right. Next, we'll see any analysis of this skewness based on these definitions. We'll analyze to know some facts. And that is, skewness is the result of lack. We will come to a conclusion with all these definitions that skewness is a result of lack of symmetry. If frequency distribution is plotted on a graph, items tend to disperse more on one side of the mean. Okay, if the frequency distribution is plotted on a graph, items tend to disperse more on one side of the mean. Okay, if you take a graph paper and if you plot the same given distribution, you will see that okay, the items tend to be more on one side and less on one side. Okay, when you consider two quadrants in a given paper, okay, if you are considering to plot the graph two quadrants and first quadrant will be more or second quadrant will be more. If first quadrant the values are more, in the second quadrant the values will be less, right? In the and next, measures of skewness indicates the direction and the extent of skewness. Measures of skewness indicates the direction and the extent of skewness. Okay, what extent the skewness is exists. Okay, and which direction the skewness is found. That means symmetry. Okay, in a skewed distribution, the value of mean, mode, and the median are not equal. Okay, in a skewed distribution, the value of mean, mode, and median are not equal. In a distribution, the more the mean, okay, moves away from the mode, the larger would be the skewness, as we have already discussed. Okay, when mean moves away from the mode, the larger would be the skewness. Okay, when the in a skewed distribution, that means mean, mode, median are not equal. Whereas in case of a symmetric distribution, okay, unskewed distribution, the mean, median, mode are equal, right? And skewness indicates the deviations of items of a particular distribution from that of a normal distribution. Skewness indicates the deviations of items of a particular distribution from that of a normal distribution. Okay, uh, it will be different. Okay, it will show some deviations when you compare the same with the normal distribution. Okay, all right. We will discuss now the objectives of skewness. The concept of skewness has gained the importance due to the fact that statistical theory is often based upon the assumptions of the normal distribution. Okay, uh, because it has gained importance because of it is based on the assumption of the normal distribution. Okay, you could able to compare the skewness with the normal distribution, right? The significance of skewness will be clear from the objectives which it has to be accomplished, right? Skewness helps us to understand the nature and degree of concentration of values in a frequency. Skewness, what it helps? Okay, understand the nature of degree of concentration of values in a frequency distribution. Okay, how they are concentrated, what is the pattern that of concentration, will come to know that in a given distribution. Degree of concentration also, right? We can also know whether the concentration of values is on the higher side or the lower side. Okay, we can also know whether the concentration of values is on the higher side, on the lower side. We know that they are not equally distributed, and if they are not equally distributed, that means they are located one side more and the other side less. The concentration, how? Okay, and we must also know the concentration, which side, higher side or lower side is more, can be known with the skewness, right? Skewness helps us to ascertain the empirical relations of various averages. It also helps us to ascertain the empirical relations of various averages such as mean, median, mode. What is empirical relation? We must know here. If some, in some cases, mode is ill defined. Okay, if you are not able to bimodal, multimodal cases, in case of multimodal circumstances, it is not possible for you to locate the mode. But with the use of empirical formula, okay, by knowing the mean and median, we could calculate the mode. Okay, they are based on moderately skewed distribution. When they are based on moderately skewed distribution, we will come to know or find the empirical relation between these three averages, right? Measures of skewness helps us to ascertain the extent to which a given distribution departs from normality. Okay, measures of skewness also helps to ascertain the extent which, okay, to which a given distribution departs from normality. Normal distribution, how it differs from the normal distribution. Okay, for to what extent it is differing from the normality. Since many of statistical measures are based on the assumptions of normal distribution, the study of measures of skewness is imperative, right? And now we'll discuss types of frequency distributions and skewness. Frequency distributions may be either symmetrical or asymmetrical, as we have already discussed symmetrical, and now we will discuss the asymmetrical and skewness. Symmetrical, a frequency distribution is said to be symmetrical when it fulfills certain conditions. What are those conditions? First condition is mean, median, mode are equal. In a normal distribution, you will find this mean, median, mode are equal. At the center of gravity, you will find mean, median, mode. Okay, these three will coincide, right? Data when plotted on a graph paper give the normal bell-shaped curve. If you take a symmetrical distribution and the same if you plot on a graph, you will get a normal bell-shaped curve. Okay, the bell, you can in case of biology students, they will find they hear that the term symmetric in two cases. One is bilaterally symmetric and the other is radially symmetric. If you can cut the given object into four equal halves, then we call it as radially symmetric. Bilaterally symmetry means you can cut the given item object into only two equal halves. This is a human being. You can cut the human being into two equal halves. You will get one here, one eye, one, okay, nose, half part of the nose, right? In that manner, right? Next, sum of the positive deviations which forms the median or mode is equal to the sum of the negative deviations. Okay, sum of the positive deviations which form median mode is equal to the sum of the negative deviations. As a balance you will find, okay, we need to find two sides must be equal. That means negative and positive. Sum of those positive deviations must be equal to the sum of those negative deviations. Okay, right. Next, lower and upper quartile decile and decile 1 and 9 and percentile 10 and 90 are equidistant from the median. Okay, equidistant from the median. They are equally distributed. Okay, there are if you find percentiles, deciles, quartiles, they are equidistant from the median. How? Lower quartile and upper quartile. Lower quartile is Q1 and upper quartile is Q3. Median is located in between these two. Median we call it as, that is second quartile, Q2 also. Median can be called as Q2 also, right? Hence they are equidistant from the median, and decile 1 and ninth decile are equidistant from the median. Percentile 10th percentile and 90 percentile, okay, 10th percentile and 90th percentile are equidistant from the median, right, in a symmetric distribution. And frequencies on either side of the mode are equal. Frequencies on either side of the mode are equal, right? uh, okay, next, frequencies on either side of mode go on increasing up to a point, then begin to decrease in the same fashion, right? Frequencies on either side of the mode go on increases up to a point and then began to decrease in the same fashion. You will find this in case of symmetric distribution, right? While some of the frequency distributions are symmetrical and bell-shaped or normal, others are symmetrical but not bell-shaped. Okay, you mean that if they are symmetrical, they may not be bell-shaped. It is not okay. They may not be, under few circumstances, they may not be found as bell shape. We will see some of them. A special kind of symmetrical distribution is the normal distribution, which is not only symmetrical but also give a perfect bell shaped curves. Some are normal distribution, okay, symmetrical, and they found distribution is the normal and which has symmetrical appearance and perfect bell shaped curves. We will see how, okay, some possible patterns of symmetrical distributions we will see here. If you look at the PPT, the first two, they are like how they are like a fork, okay, fork with the middle some another what we call it as a leg. That is, these two are symmetrical but not the bell shaped or normal distribution. Okay, we can't say these are they are. And the third one is in the normal distribution, but these two symmetrical but not, they are not bell shaped curves. They are not bell shaped curves. Okay, you, if you see them, they are symmetrical. You can make them into two equal halves, one from the origin and the other from the line drawn perpendicular to the x-axis in the second case. Okay, whereas in the first graph, the line drawn from the origin of the from the origin, okay, that is cutting the given symmetric into two equal halves, correct? Whereas in normal distribution you will find this is where symmetrical and it's a bell shaped curve. You can make it into two equal halves, right? And you will find the fourth and fifth are symmetrical but not bell shaped. Okay, bell shaped but not bell shaped. They are not normal distributions. One is in the form of D and the other is in the form of a triangle. You can cut them into two equal halves, but they are not in a bell shaped manner. They are not following the normal distribution pattern, right? These types of distributions you will find in symmetric. Now we'll see um, types of frequency distributions and skewness. So the second will be the skewed and asymmetric distribution. Second, okay, any distribution that departs from normality is called skewed distribution. If a given distribution is okay, differs from the normality, that we can say skewed. Whether it is, what extent it is skewed will be compared. That's it. Next, skewed or asymmetrical distribution may be either positively skewed or negatively skewed. It may be positively skewed or negatively skewed. We'll see what is positively skewed. Okay, positively skewed distribution. In a positively skewed distribution, the value of mean is maximum. Okay, if you find arithmetic mean, the value of arithmetic mean is maximum, and that of mode is minimum. Mode will be the minimum. You will see, mode will be the minimum, mean will be the maximum, and mode will be the minimum. Okay, uh, median lies in between these two extremes. Median lies in between these two extremes. When you see the PPT, you will come to know what is okay, which is minimum, which is maximum, and in between these two you will find the mean. Two extremes you will find the median. In a positively skewed distribution, more than half of the area under the curve falls on the right side. If you see, more than half of the uh, area of the curve under the curve falls on the right side of the mode. On the right side of the mode, if you see that PPT, you will come to know this. Okay, mode is at left extreme, and after mode you will find lot of area that is covered under the curve. Okay, and its right tail is longer than its left. Even you see, right tail is longer when you compare with the left tail, right? Under such a distribution, mean is greater than median. Okay, mean is greater than median, and uh, the median is greater than the mode. Okay, the median is greater than the mode. When you see the PPT, you will come to know that the difference between the upper quartile and the median is greater than the difference between the median and the lower quartile. That means Q3 minus median greater than median minus Q1. Okay, the difference between upper quartile and median is greater than the difference between the median and lower quartile. If you see the PPT, the graph, okay, the properties of this positively skewed distribution can be understood with that graph. Mode is in the left side and the mean is on the right side. If you observe the area covered under this graph, okay, from left side to the main mode is less than the right side to the mode, the area covered by the distribution. This is a positively skewed distribution, right? Now we'll move on to negatively skewed distribution. Okay, in a negatively skewed frequency distribution, mean is less than median. Okay, mean is less than median, and median is less than mode. Okay, mean less than median is less than mode. If you see, the tail extended to the left side. Okay, in other words, we can say that the value of mode is maximum, and the tough mean is minimum. Mean is minimum, right? uh, the value of median lies in between these two extreme values, and more than half of the area under the distribution curve falls on the left side of the mode. Reverse to that positive skewed distribution, you will find here the value of median lies in between these two values, and more than half of the area under the distribution curve falls on the left side of the mode. Okay, the area covered on the left side of the mode is more here in case of a negatively skewed distribution, whereas in positively skewed distribution, the area covered under graph to the mode right side of the mode is more, right? And thus we can the excess tail be on the left side of the curve. If you see, the tail extended to the left side of the curve. Okay, the difference between the uh, quartiles and median will be that means the difference between the upper quartile and median, okay, is less than the median, uh, the difference between the lower quartile and median, that is Q3 minus m, okay, is less than m minus Q1. That means the difference between the upper quartile and median is less than the difference between the median and lower quartile. With the help of the figure, we can depict that condition in the negatively skewed distribution. If you look at, you will find that median is in the center and mode is at the right corner. Okay, mean is at the left corner and the tail is extended towards the left side, right? Now we see tests of skewness. There are a few steps, can be applied to ascertain whether a frequency distribution is symmetrical, or it is skewed. Whether the given distribution is symmetric or skewed, we can ascertain with the help of a few tests. First one is in an asymmetrical, or we can say skewed distribution, mean, median, mode are not equal. This is one thing we should first look into the thing. That is mean, median, mode are not equal. The greater the difference between the mean and mode, the greater the difference between the mean and mode, more would be the skewness in the distribution. More would be the skewness would be the more, right? In the second test, in a moderately skewed distribution, mean is equal to mode plus 2 by third of median minus mode. Mean is equal to mode plus 2 by third of median minus mode in case of moderately skewed distribution, right? Third is the data of any asymmetrical distribution. The data of any asymmetrical distribution when plotted on a graph paper do not give a bell-shaped curve. If you find the bell-shaped curve, that is not a skewed one. The data of an asymmetrical distribution when plotted on a graph paper, it won't give bell-shaped curve. That means it is skewed distribution, right? That confirms that it is a skewed. The vertical line through the center does not cut the curve into two equal halves. That means that is not a bell-shaped. When that is not a bell-shaped curve, you are not in a position to cut the same into two equal halves, right? Next, in a skewed distribution, the sum of positive deviations from median or mode is not equal to the sum of negative deviations. Whereas in symmetrical distribution, the sum of positive deviations must be equal to the sum of the negative deviations. That's why only we will get the bell-shaped curve. Whereas in case of skewed distribution, it was not so, right? The sum of the positive deviations from median are not equal to the mode is not equal to the sum of the negative deviations, median mode, right? The degree of skewness depends upon the difference between the sum of positive and negative deviations from median or mode. How can you calculate the degree of skewness? How would you come to know the degree of skewness? What extent it is skewed? With the aid of the difference between the positive and negative deviations from median or mode, by calculating the difference between the negative deviations, the difference between the negative and positive deviations from median or mode, we can conclude. And next one is in a skewed distribution, frequencies on either side of the mode are not equal. If they are equal, it's a bell-shaped and symmetrical. The skewed distribution frequencies on either side of the mode are not equal. That's it. In a skewed distribution, the values of lower quartile and upper quartile decile, 1 to decile 9 and decile 1 to decile 9 and percentile 10 to percentile 90 are not equidistant from median. If they are all equidistant, if as we have gone through it, lower quartile and upper quartile are equidistant from median, and decile 1 and 10th decile are equidistant from median, and percentile and 10 and percentile 90 are equidistant from median, then it is a symmetric distribution, that is not a skewed distribution. These tests will help us whether the given distribution is skewed or not. A table has been tested in order to make it lucid. We will have a table. If you see the table, size is given 20, 40, 60, 80, 100, 120, 140. This is skewness. Frequency 1, frequency 2, frequency 3. Frequency 1, 2, 6, 10, 14, 10, 6, 2. Center value is 14 and either side you have the same frequency, then it is symmetric. Whereas if you see the second frequency, 2, 18, 10, 8, 6, 4, 2 are given. Okay, positive skewness. This is positive skewness. Whereas in case of third frequency, if you see at the frequency values 3, 4, 7, 7, 10, 18, 2 has given, it is negatively skewness. Average based computations of skewness, if you take x bar is equal to median is equal to mode in case of symmetrical distribution. Okay, here x bar is nothing but arithmetic mean, med is equal to median, which is equal to m0 means mode. Okay, whereas in second frequency distribution, x bar greater than median, x bar, that is arithmetic mean, is greater than median, median is greater than mode. Whereas in case of third frequency distribution, x bar less than median, okay, and median less than mode. Okay, if you consider the computations of skewness, whereas symmetric, 80 is equal to 80 is equal to 80. Okay, that means the center value, size of the item located to the center value, that is 80. Okay, that is median, arithmetic mean 80, median 80, and mode, the highest frequency that we got is 14. 14 corresponding value is 80. Hence, uh, mean is equal to median, which is equal to mode. Whereas in case of mean is second frequency, if you observe the second frequency 67.2, which is greater than median. Median you will get 60. Okay, median. Okay, median you will get as 60 and mode is 40. Okay, the number which occurs more number of times by the observation method will confirm that 18, the frequency number of times occurring is 40, the corresponding item is 40, hence the mode is 40. That means 67.2 greater than 60, 60 greater than 40 in case of second. Whereas in case of third frequency, you will get x bar value is 92.4, okay, which is less than 100, where median is 100. Okay, where median is 100 and 100 is less than 120, where mode is 120. Okay, where mode is 120. How can you say that? If you size of the now sum of the items by number of items, okay, the frequency, if you multiply with the frequency you will get x bar. Okay, n plus 1 number of items and you make it cumulative frequency and you will get the median. And in the same manner, number of observations, that is high. If you see in the third frequency there are 18, corresponding value is 120. Okay, 120 has occurred many times, 18 number of times. No other item can be near to this item, hence 120 is confirmed as mode. Next we will see quartile based computation. Q3 minus median, okay, is equal to median minus Q1. Q3 minus median, Q3 is 100 minus median is equal 80. 80 minus, okay, and Q1 is equal to 80, median is equal to 80, sorry, minus Q1 is equal to 60. 100 minus 80, 20, 80 minus 60, 20. They are equal, they are symmetric in case of first frequency. Whereas in case of second, that is Q3 is 100 minus median is 67.2 and lower quartile is 40. That is 100 minus 67.2, 67.2 minus 40. That means 67.2, how much you will get? 32.8. 32.8, which is not equal to the 27.2. Both are 32.8 is greater than 20, what we call it as 27.2, right? This is also confirmed. And in case of a third frequency, the Q3 is 120 minus median is 100, okay, which is less than 100 minus 60. 120 minus 100 is equal to 20, you will get 20 is less than 100 minus 60, 40. Okay, that means 20 is less than 40, which is confirmed that x bar is less than median, median is less than mode according to the third option, right? And shape of the curve, okay, shape of the frequency curve is, in case of first frequency curve, it is symmetrical, hence it is normal. Whereas in the case of positively skewed to the right, okay, that is skewed to the right. Whereas in the third frequency distribution, skewed to the left, skewed to the left. Note, we will come to a conclusion that note x bar is equal to mean. From if you see med, as I already explained, MED means median, M0 means mode, Q3 is nothing but upper quartile, Q1 is nothing but lower quartile, right? Next, distinction between dispersion and skewness. Okay, what are the differences or distinctions? Where distinction we will have between the skewness and dispersion. Some of the important points of points of difference between dispersion and skewness we will discuss here. First, dispersion. It is a measure of variation of the items in a frequency distribution from a central value, right? Whereas skewness, it is a measure of symmetry of distribution of values on both sides of the central value. Whereas dispersion is, it is the average of the second order, because it is an average of deviation around a central value. Okay, it is the average of second order because it is an average of deviation around a central value. First we will calculate the central value, then we will look for the average differences. Okay, second order will how the deviations will around it. In case of skewness, it is not an average, but its measurement is based on various types of averages such as mean, median, mode, etc. Right? Dispersion, in case of dispersion, it measures the degree of variability in data, whereas in skewness, it helps to find out whether the concentration of values is on positive or negative side. Right? Next, in case of dispersion, okay, it is concerned with the variability of values in general, and in case of skewness, it is concerned with the symmetry of distribution on either side of the mode. In case of dispersion, it is concerned with the general shape of frequency distribution. In case of skewness, it is concerned with the dispersion on the two sides of the mode with regard to the arrangement of frequencies. In case of dispersion, it indicates the extent to which a mean is representative of individual values in a frequency distribution. In skewness, it helps in judging the extent to which a given frequency distribution departs from normality. Right? Now we will discuss absolute measure of skewness. Having seen the theoretical and graphical presentation of skewness, now an attempt is made to calculate the coefficient of skewness with the help of Karl Pearson and Bowley's formula. Okay, the extent and direction of symmetry in a series is calculated with the help of statistical measure of skewness. Okay, these measures can be absolute or relative, right? Absolute measures of skewness tells us the extent of asymmetry in a series in absolute terms. Okay, according to this, skewness is calculated simply by obtaining the difference between the mean and mode of the given series. Okay, if you show this symbolically, absolute skewness is equal to x bar minus z, where x bar is nothing but arithmetic mean, z is equal to mode. According to this method, if the value of mean is greater than mode, the distribution is said to be positively skewed. On the other hand, if the value of the mode is greater than mean, the distribution is said to be negatively skewed. Okay, to find out the absolute measure of skewness, the difference between mean and mode is used because of the fact, okay, that in a symmetric distribution, the value of mean, median, mode are alike, but in an asymmetrical distribution means moves away from mode on either side. Hence, the distance between mean mode is used to measure the skewness. The greater the distance between the mean and mode, whether it be positive or negative, the more would be the asymmetry in the distribution. Okay, right? When skewness is calculated on the basis of quartiles, formula used for this is absolute skewness is equal to Q3 plus Q1 minus 2 median. Okay, 2 median. Right. Next, relative measures of skewness. Okay, and before this, absolute measure of skewness is constituted to be unsatisfactory on account of certain points. One is absolute measure of skewness is expressed in the same unit of value in which the values of distribution are expressed. Hence, absolute measure of skewness, okay, is not useful to compare two or more distributions whose values are expressed in different units. Two or more distributions may be either similar frequency curve, but in one series the difference between mean and mode in absolute terms may be greater, while in others it may be smaller. Thus, absolute measures of skewness do not help to compare the frequency distribution. Right. Next, relative measures of skewness we'll discuss. The absolute measure of skewness, which is expressed in relation to some measures of dispersion, is called relative measures of skewness or coefficient of skewness. Relative measures of skewness gives us a pure number which is independent of the units in which the values of distribution are expressed. This enables us to compare and interpret the results of two or more distributions whose values are given in different units. Right? There are four important methods of relative measures of skewness. Only we will hear, of course, there are four. I'll tell you. The Carl-Pearson coefficient of skewness is there, the Bowley's coefficient of skewness is there, the Kelly's coefficient of skewness is there, and measures of skewness based on moments also there. We will discuss here Carl-Pearson and Bowley's. First, we will see the introduction, and in the next class, we will go with the numerical problems of continuous series of Carl-Pearson coefficient. Right? First, we will see Carl-Pearson coefficient of skewness. Okay, Carl-Pearson coefficient of skewness. In this, according to Carl-Pearson, skewness is calculated by using a formula, that is Carl-Pearson skewness is indicated by SKP. Okay, which is equal to mean minus mode by standard deviation. Mean minus mode by standard deviation. Okay, characteristics of Carl-Pearson coefficient are coefficient of skewness is 0 for a symmetrical distribution. In a positively skewed distribution, the value of mean is greater than mode. In a third one is in a negatively skewed distribution, the value of mode is greater than the mean. And fourth one is theoretically this measure varies within the limits of which plus or minus 3 is rare phenomenon in the real life. We can't find the same in the real life phenomenon, right? Usually it varies in between plus or minus 1 in case of real life, but here we took this theoretically plus or minus 3. Okay, that is a rare phenomenon in our real life, right? This formula is not useful to calculate skewness for a bimodal frequency distribution. Hence, Pearson has suggested another formula, that is called empirical formula, that is SKP is equal to 3 mean minus median by standard deviation. Right. Next, we will do one problem on this. Of course, the equation given by Carl-Pearson, okay, based on the relationship different averages moderately asymmetric distribution, will make it different. Mode is equal to 3 median minus 2 mean. Mode is equal to 3 median minus 3 mean plus mean. Mode minus mean is equal to 3 bracket of median minus mean. Okay, if the value of mean and mean is submitted, we will get that is Carl-Pearson coefficient of skewness. SKP is equal to 3 mean minus median by standard deviation. Okay, this is a third equation that will come to know. With this, we'll calculate the coefficient of skewness. Okay, he has given weekly wages. They are represented with red color, and number of workers. Okay, this is given in the exam question. What we need to do is we have to solve only for the as we are explaining the same in the PPT. I am not considering the question, okay, different from the solution. Okay, in the table I am considering both, hence I am representing differently. Wages is given X, I am taking a weekly wages are given in rupees, I am taking it as X. and number of workers as frequency, and based on this x minus here, in order to make the first, we need to make the calculation of arithmetic mean. We will find the arithmetic mean, and based on that we will find the deviations. Okay, d dash we call it as. Okay, and that is required for calculation of SKP. Hence, I am in order to find out the x bar, I am taking assumed mean as 90. Okay, in the given series, x minus 90 by, okay, the, that is a common factor c. Okay, it is, as the figures are big, make it okay, easy for calculation. I am considering 15 as common factor. Okay, that will exist in all the given values, hence which is equal to d dash x minus a by 15. That is, as we know that x value is 45, first value is 45 minus 90. Okay, 45 by 15 minus 3, 60 minus 90, 30 by 15 minus 2, okay, 75 minus 90 by minus 15 by 15 minus 1, 90 by 90, 90 minus 90, 0 by 15 is nothing but 0, 105 minus 90, that is 15 by 15 is 1, 120 minus 90, 30 by 15 is 2, 135 by minus 90, okay, 45 minus 45 by 15 3, 150 minus 90 is equal to 60 by 15 is equal to 4. These are the d dash, these values are called as d dash, and now we need to multiply d dash with the frequency. Minus 3 into 6 minus 18, minus 2 into 50 minus 100, minus 1 into 38 minus 38, 0 into 32 0, 8 into 1 8, 10 into 2 20, 12 into 3 36, 4 into 4 16. Now ft dash square. Okay, in order to remove the negative signs, d dash square into f, d dash square we have to calculate, that is d dash square is nothing but minus 3 into minus 3 9, 9 into 6 54, minus 2 into minus 2 4, 4 into 50 200, minus 1 into minus 1 plus 1 into 38 38 only, 0 into 30 0 whole square is nothing but 0, 0 into 32 0, 1 into whole square 1 means that is 1 only, 1 into 8 8, 2 into 10, that is 2 whole square is equal to 4, 4 into 10 40, 3 whole square is equal to 9, 9 into 12 108, 4 whole square is equal to 16 into 4 64. You will get, if you add all these values, sigma fd square, if you add the sigma d dash square d dash values, you will get sigma d dash, that is minus 17. Number of items are 160, that is sum of the frequencies we call it as. Sigma fd dash square values are 512. If you substitute the same in the given formula, first we have calculated that x bar is required here, that is a assumed mean, we know that 90 plus minus 76 by 160 into 15 is equal to 90 minus 21 by 4, which is equal to 90 minus 7.125, which is equal to 82.87, that is x bar. We know the standard deviation formula, that is small sigma is equal under root sigma fd dash square by n minus sigma fd dash by n whole square into c. Sigma fd dash square is equal to 512, sigma fd dash is equal to minus 76, n is equal to 160, c is equal to 15. Substituting the values in the formula, we will get sigma under root 512 by 160 minus 76 by 160 whole square into 15, under root 3.2 minus 0.4752 whole square into 50, 3.2 minus 0.226 into 15 15, 3.2 minus 0.226 is equal to 2.97 under root into 15, under root 2.974 is equal to 1.723 into 15 is equal to 25.845. Now, in order to find out the mode that is required to calculate the Carl Pearson coefficient of skewness, we will consider grouping table. If you see at the look at the PPT, you will come to know what is grouping table, how it will be calculated. First column is taken wages, corresponding to the wages. We have to consider the first column. First column are nothing but the frequencies given in the question. Okay, if you add 2 to in the first column, you will get the second column. Okay, 6 plus 50 56, 38 plus 32 78 plus 10 18, 12 plus 4 16. Okay, after third column, what you need to do, by adding the two twos you will get the second column. By adding the first one, leaving the first frequency, if you add the two, then you will get the third column. That is 50 plus 38 88, 32 plus 8 40, 10 plus 12 22. The remaining 4 is left because it don't have any pair. And in the fourth column you need to add 3 okay, group the 3 frequency items. That is 56 6 plus 50 56 plus 38 94, 32 plus 8 to 40 plus 10 50. Okay, in the column 4 you will get the 3 group item sum, right? In the column 5, leaving the first item, add 3 that is 50 plus 38 plus 32 120, 8 plus 10 18 plus 12 that is 30. Okay, in the sixth column, leaving the 2, we need to add the 3 that is 38 plus 32 uh, 70 plus 8 78 plus 10 plus 12 22 plus 4 26. And with this we will come to know the grouping table has completed. And now based on the grouping table we will take analysis table. Okay, analysis table will be considered. Analysis table, if you look at the analysis table, you will have one in the analysis table. Above you will find the same grouping table. Okay, for the better understanding I wrote this. And okay, in the second you will find the analysis table. Okay, in the PPT. In the analysis table, first column numbers are written in the first column, and in the first, second, third, fourth columns are taken as their corresponding x wages in rupees. That is x values. 45 occurred when you see 45. That is in the fourth column. It is more number of times occurring. In the hence it is one only. Whereas a 60 occurring in the first column, okay, more number of times in the third column, in the fourth column, in the fifth column, hence 4 number of times it is occurring. When you take the 75 is occurring second, third, fourth, fifth, sixth column. Okay, that is 5 times it is occurring. And whereas 90 is occurring in the second column and in the fourth and fifth and sixth column. Whereas in case of 105, which is occurring only one time, that is in the sixth column. Hence, if you add all these, the 75 number which occurs more number of times, that is 5 times, hence the modal wage is considered as 75. And now we need to uh, substitute the same in the Carl Pearson coefficient of skewness formula, that is mean SKP is equal to mean minus mode by standard deviation. We know that mean is equal to 82.87, whereas mode is equal to 75, and standard deviation that we have calculated already is nothing but 25.845. Substituting these values in the formula, you will get XP. Okay, SKP is equal to 82.87 minus 75 by 25.845, which is equal to 7.87 by 25.845, which is equal to 0.304. Thus, a series is positively skewed. We will come to know that series is positively skewed, right? Note, in case of frequency of one class is distinctly higher than the other class frequency, the student can locate the model group by observation without restoring to group method, right? With this, we have concluded this class of, okay, skewness, results of skewness. Thank you.